A very useful application of freezing point depression or boiling point elevation is the experimental determination of molar mass of unknown substances. Because by measuring the freezing point depression, we can calculate the molality of a substance. And if you know experimentally the mass of that substance, you can calculate the number of moles and therefore the molar mass of the unknown. In this example, we have a substance called anethol. It's used as a flavoring agent. It's very sweet and has a flavor similar to licorice. In a freezing point depression experiment, the molality of a solution that has 58.1 milligrams of the unknown and 5 grams of benzene was determined to be 0.0784 molal. So we are determined the molality of the solution. We know the mass of the solute, the unknown, and the mass of the solvent. So can we calculate molar mass of this substance? We have two equations to work with. Remember, molar mass is the mass of the sample of a substance divided by its number of moles. Therefore, giving you a quantity in grams per moles, the molar mass. And molality is the moles of solute per kilogram of solvent. To calculate molar mass, we are given the mass of the substance, 58.1 milligrams, and the number of moles is calculated from the calculated or experimentally determined molality. When plugged into this equation, the result will give you the molar mass. So here are the solution steps. We know that molality is moles of solute divided by kilograms of solvent. We are given molality, we are given the mass of solvent, and we don't know the moles of solute. That is the only unknown out of this equation, so we can pull it out. The given molality is 0.0784 molal, or moles per kilogram. The solvent is given to be 5 grams. Of course, we have to convert that to kilograms because in the molality expression, mass of solvent must be in kilograms. Therefore, at this point, we can calculate, after plugging in the given values, the moles of solute from this equation, which is 3.92 times 10 to negative 4 moles. And the solute mass that was given in the question was 58.1 milligrams. It is 0.0581 in gram units. So dividing the given mass in grams by the moles calculated from molality, we calculate the molar mass to be 148 grams per mole. Let's see another example of molar mass determination using freezing point depression. This time, our substance of interest is thyroxine, a hormone. In the experiment, a 0.453 grams of this substance is dissolved in 10 grams of benzene, and the freezing point was determined to be 5.144 degrees Celsius. We are also given the freezing point of pure benzene and the freezing point depression constant of benzene. And again, we're asked the molar mass of thyroxine. We are going to use the molar mass formula. We're going to divide the mass by the number of moles of the substance. And we're going to use the freezing point depression equation, where molality times freezing point depression constant gives you how much the freezing point has decreased. Remember, molality is equal to moles of solute divided by mass of solvent. So molar mass is going to use mass coming from the given value and the number of moles from the freezing point depression equation. The first step is to resolve this equation, the freezing point depression equation. Molality times freezing point depression constant. You need to write molality in expanded form, moles of solute divided by mass of the solvent. What is the freezing point depression? How much did it change? We are given the pure benzene freezing point and the freezing point of the solution. The difference is how much freezing point got depressed, 0.3. And to use this in this equation, the mass of the solvent must be converted to kilograms from the given unit of grams. And Kf is given as 5.12 degrees Celsius per mole. But for unit calculation purposes, write the molality unit expanded as moles per kilograms. Plugging it into the equation, this is the freezing point change. Moles of solute is what we're going to get from this equation, divided by mass of the solvent times the freezing point depression constant. The moles of solute calculates to be 5.86 times 10 to the negative 4 moles from this equation. Because we were given the mass of the compound, dividing that mass by the calculated mole, we get the molar mass to be 773 grams per mole. Now pause and answer these questions for practice. Here's another example for you to solve for the molar mass determination using freezing point depression.